Okay, let's move to problem. Which this is 4. Okay, problem 4 is not terribly hard. So there's these two speakers, and the student starts off equidistant between them, and some distance, and then she walks down here. She hears the loud sound, gets soft, and then loud again. The speakers are in phase. So this is really a, in case you didn't figure this out, this is an interference problem. So what's critical here is S2 minus S1 equals, and she spends her time on antinodes mostly, so we're going to go with that. So at point A, M equals 0, and I think it's pretty clear at that point also that S2, which is the distance from her to speaker 2 and from her to speaker 1, are the same. So, well, that all works out. Actually, I guess that's how you know that you're at M equals 0 because, well, yeah, I mean, that's got to be it, right? The wavelength can't be 0. So she walks down to B, and basically at point B, I'm not going to go through the details, but it turns out S2 is, let's see, 13.0 meters, and S1 is 15.0 meters. And so, yeah. Well, I guess the way I've numbered them is backwards, but whatever. So S2 minus S1 equals negative 2.0 meters, which means then, so this has got to be m times lambda, right? And so the question then is, what's the value of m here? And so the problem description says she starts off with it loud here at A, and then walks through where it gets very soft in the middle, and then she gets back to loud at B. And so that's an indication that she's really only on node line 1 or node line -1. So it doesn't really matter which one. This m here, sorry, is meters. This is m, so sorry about that. But since m equals -1, that means lambda equals 2.0 meters. So that gives you the wavelength, which was part A. Part B, you just use V equals F lambda. You know V because it's given, and so you get F equals 172 hertz. And then for C, let's see, what does it say? The frequency of the sound is increased to 12 times its initial value. She walks back along the path to her original position. So the question is, how many times is she going to go from, or how many antinode lines is she going to cross? Or I guess how many node lines is she going to cross? She crossed one node line, which probably went something like this to get through there. And so basically from here to here, yeah, she went from antinode to node to antinode. And so it's not terribly hard to see then that S2 minus S1 is still going to be the same here. It's still going to be 2 meters. And so if lambda, well, if the frequency gets increased by a factor of 12, then lambda is going to go down by a factor of 12, right? Which means then in order for this to still be a valid equation with this 2 meters, m has to go up by a factor of 12, which means it goes from -1 to -12. So now when this sound's frequency is multiplied by 12, she's on node line -12, and she's still walking back to 0, which means she's going to hear the sound go down and then up 12 times. So there you go. That's the skinny on problem 4.